Good morning, students. And this is Suraj Patil, and welcome to Maths Chef YouTube channel. Okay. Yesterday we have discussed about the chapters and their weightage in the marks. Okay. So today we start the first chapter. Randomly we can start any chapter, especially calculus or something else, but it will be better going what the first chapter means. Okay. At least everyone they given first chapter means there should be some hierarchy order. Okay. They would have given the first as a calculus, some function combinations, some geometry, but they given first chapter means there should be basic knowledge to the next chapters for all subjects. Okay, that's why in class 11 also I started first chapter, class 12 also I'm starting the first chapter, and my reference material is this one. Okay, understanding ICSC mathematics, class 12 into elements the value 1. And IPC publication, RA publication, right? ML Agarwal, same author is ML Agarwal, and RA publication. This is the available in the market, the 50% discount for old book 2022 edition, I think so. This is my reference for the whole video, whole chapters, almost all. So, so any doubts, any queries, any mistakes, any misconceptions arised by me while teaching, please take a screenshot or comment on the page number or comment on the YouTube page number on the YouTube channel, right? Okay, let's start the introduction. Okay, start the introduction means what? The first chapter is then relation and function, right? Relations and functions. Relations and functions. In class 11, we have studied the sets and relations, right? Sets and relations. Sets and relations in class 11. Okay. There we have the some very interesting concept, sets and relations. Okay, sets and relation and little bit about the functions. Okay, in relation, see they have the set, right, is equal to 1, 2, 3, general set. Okay, set is the consider the standard fixed numbers. Okay, they have different number. Okay, then again they have the some peculiar concept, right? A cross A is called A cross A, called Cartesian products. Cartesian products. How it is like that? This is like that. Okay, there are two sides. Okay, A is equal to 1, 2, 3, and again A is equal to 1, 2, 3. Right. Okay, this I am going to write this as 1 and 1. Okay, right? This is called ordered pair. Right? What is called ordered pair? Writing this system 1 and 2. Okay, 1 and 3. Next, second element 2 and 1, and 2 and 2, and okay, 2 and 3, right? And again third element 3 and 1, 3 and 2, and 3 and 3. Okay, the system, the whole set is called Cartesian sets or Cartesian products. Okay, the elements writing in this space is called ordered pair. Ordered pair means that have some relation. Yes, here 1 is equal to 1, 1 is less than 2, 2 is equal to 2, 2 is less than 1, something in order. Okay, they have some definition, some relations. This is called ordered pair. Okay, writing this system. Okay, called ordered pair. Pair means 2, right? Similarly, the relation. Okay, the definition of relation is okay. R is any subset of A cross A. Okay, R is any subset of A cross A. Right? You can write. Okay, R is any subset of subset of A cross A. Okay, here this is R, this is R, this is R, this is all. Okay, sir. Everyone is R. You can take the 2, 3 also. This 1 and 2, 2, 3, 3 is also are collectively R set space. A and B are equal to 1 like that, okay. R is the set, okay. R is the relation such that R is the relation, okay, set such that A is equal to A, can write, or A is equal to B and AB belongs to, okay, and AB belongs to A. This is the set builder form, right? Set builder form. They have the roster form, set builder form. Let B. Can write this one as, this is like that now for considering this session. This is R is equal to, right? This R is equal to here. R is equal to 1, 1 and 2, 2 and 3, 3. Okay, sir. R is the condition is R is equal to A and B. Right? Similarly, R is any subset. R is any subset of A cross A. Right? R is any subset. Means relation is any subset of A cross A. R is relation. Relation is any subset of A cross A. Similarly, let's define this some function also. Okay. Then because we are getting some clarity for the function means also. Here function is, okay, for the function. Okay. See here any subset you mentioned here, okay. Any subset, but function is not like that. Function is a special subset of R. Okay. Function is a special subset of R where all elements of A are utilized here. Okay. Here like that, this is the function A and this is the set A. Has 1, 2, 3. Here has 1, 2, 3. The condition, okay sir. The condition, see, R may be 1 and 1, but the function may not be 1 and 2. Okay. Function should have at least, okay, should this elements. Okay, right. Function. This is the condition. Function, the domain function should be used. Okay, all should be used. Means should not be a left the single element in function. Okay. In function we have, okay, injective, bijective, different that comes in the next concept. But function is, okay, the input is completely used to get the output. So here you can have the again 5, 6. Okay, it did not matter. It is the codomain range. But our domain should be utilized completely. Okay. Then it is called function. If okay, this is the main condition. Okay, where the domain should not leave a single element while they considering the function. So R, okay, this is also R, this is also R, and this is also R. We can write, but function not R. This is the concept. Okay. Right? All A should take the all elements in the A. Means every image at least should have one pre-image. Right? Every image at least should have one pre-image at least. Okay? Right? That is the condition. Function is a special subset of R relation. Special subset of relation. Okay. So to the first class, we will enter the new syllabus. Okay. To the class 12 chapters. This is the basics only. Sets and relation. A class is called Cartesian product or Cartesian system, and is the ordered pair writing in the two brackets. Okay. And R is the relation is any subset, okay? Any subset of the A cross matrix. Any subset. There is no condition. Okay, you can take whole, take a whole. But the function is, you can take only every image, at least have one pre-image. Right? This is the definition of the function. Means In simple, we should not leave a single element in the domain. Okay, you should not leave the single element in a domain, this cell. Okay, this is the function. Let's see the next new concepts, new chapters. Okay, new. Okay, they give us some new concepts. Let's start and solve the questions afterwards, right? Okay, sir. Okay. Next, the first concept. Okay, in this chapter, now you know the introduction or the set and relation. So first, relation on a set. Okay, already you know. Now the definition is R is a any subset. Okay, relation is a relation, right, is any subset in a universal set. Okay, can write instead of calling universal in A cross A matrix. Okay, in A cross A matrix. Okay, and where A belongs to in A cross A. So A belongs to any cell. Okay, can A is the set of Z. Okay, positive numbers, natural numbers, whole numbers. Okay, you can take the any numbers, you can real numbers also, complex numbers also, but real numbers, complex numbers, you know how deep it is. It's quite difficult to define the relation somewhere else. Okay, simply take the any sum. This is called relation. Okay, okay, this relation is any subset in a cross. Can I write this one as relation is any subset in the matrix A cross A. Okay, A is any defined set, right? So first concept here is empty set. What is empty set? Not empty relation. So in a previous class, okay, in a set here should be empty set and universal set like that. Similarly here, empty relation. Okay, empty relation means, so let's take elements. A is equal to 1, 2, 3, right? And A cross A, you know. A cross A, you know. I will write, may I write again? A cross A, 1, 1, 1, 2, 1, 3, 2, 1, 2, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3, like that, na? Right? With the universal set, okay? If, let's take 1, 1, 1, 2, 1, 3, can I write this one as 4, 2 is belongs to A cross A? Not? Right? Therefore, this can I write empty set divided by the 5. Okay? 5. So, 5 is a subset of A cross A. Because here you can write any space. Now space means KC. The 5 is nothing but see in set value. 5 is like a 0. So in multiplication is like 1. Okay. See in 2 plus 0 is equal to 0 plus 2 in addition. Right? Again 2 into 1 is equal to 1 into 2 is equal to this is the multiplication, right? Similarly, can define, but still 0 is in the operations. That's why 5 is the not, okay, this is the not definition. Okay, 5 is the empty set. So empty set means there is no elements in the like that, A cross A. 5 is the empty set. Okay. Next one is again. Okay. This is called empty relation. Okay, this is called, how can I write? This is called empty relation. So called no relation. Empty relation. Also called empty relation, right? Second one is universal relation. universal relation. Okay, let's take given condition. One thing I should tell, a relation is in terms means operation, mathematical operation specifically, or mathematical condition. Okay, relation is like that: a plus b, a minus b, a into b, a by b, a to the power b, b to the power a divides b, right? A log b and e to the power a, whatever it may be, okay? Mod of a minus b mod, and a plus b is equal to some standard value, a minus b is equal to some standard value. See, wherever they use the relations, no, they give some operations, conditions, mathematical notations. Okay, from this definition we are going to tell the whether the relation is empty, universal, that reflexive, symmetric, something and relation. Okay, only based on these conditions, given relations, given conditions, given operations, given mathematical definitions, we are going to use to define the what is the relation it is. Okay, set is different. Set you can take the randomly, yes or not, it belongs to or not. But relation have to make some mathematical operation. That's why in the given, take the, see, this is the 1 plus 1, 2, 3, a cross k. Take the a plus b is equal to 10 condition. Okay, from here condition a plus b is equal to 10 means you should take the a and b such that it belongs to 1, 2, 3. Here also 1, 2, 3. The sum of two number we are getting should be 10. Okay, does this set has any pair, ordered pair? To get this sum as 10, value as sum as 10, right? Not, right? Because at least we need 6 plus 4. 6 is not belongs to a and b not belongs to 4. Therefore, can I write this one as a and b, okay, belongs to R is an empty relation. Empty relation on empty relation on or a cross a. Right, sir? This is the mathematical notation. If you take any a plus b or b, it's not below k. It's not a no empty relation. A plus b is a, because a cross b is not belongs to, right? What should I write? A cross b not belongs to a cross a such that a plus b is equal to 10. Okay, this here also you can write not belongs to R because we do not have any relations, right? Called empty relations. Okay, next term is universal relation. Next one is universal relation. Second one is universal relation, right? What the universal relation is? Let's take the a cross a again. A cross a is equal to 1, 1. I am writing 1 and 2 and 1 and 3, 2 and 1, 2 and 2, 2 and 3, 3 and 1, 3 and 2, and 3 and 3, right? And define the relation relation, I'm taking the relation as a minus b mod is greater than 0. Yes, sir. The relation, condition, mathematical operation, mathematical notation. Okay. The condition is a minus b, means the difference of the two elements in this order pair is greater than 0. Condition is. Right, sir. By doing this operation, right, sir, by doing this operation, can I get the elements as same elements, a cross a? Right, sir. In empty relation order, I have taken the a plus b is equal to 10. Okay. See, in a relation have, so I do not have any elements because my elements are only 1 and 2. Maximum is 3 plus is 6. Maximum value, sum of the two values is 3, but they given 10. So this is the 5, right? And 5 is subset of all any elements, right? That's the definition. So this is called the universal relation. Okay, universal relation. This is right. Universal relation. A minus b mod of a minus b, or positive value of 2. Okay, positive value of two different numbers. Okay, mod of two numbers is equal to 0, or the two numbers should get the two positive values. Then now they give us an, and this both empty relation plus Cantal and universal relation called trivial relation. Right? See, occasionally I am referring the books to get this book to get the points. Okay, while teaching, if you skip this some points now, again they see this definition. Meaning, even though you have the mind, I can tell the, but it mixes the orders while teaching the order interchanges something else somewhere else. Okay, that's why occasionally. So when taking the question papers, I taking the start the new concept. So I usually see the books while teaching. So these the empty relation and universal relation. Okay, sir. Why I am saying, see, without PPT, okay, with PPT we can do anything else, right? With PPT, everything is on the digital board. Our work is just explaining the steps, how it came. Anyway, I already have done a lot of work before starting the class. But this is also, even though I have done the hard work or smart work before going to start the class, still we missed some important points. To overcome that one, I openly telling, I use those books only for take the points and some examples, some methods. Okay, if I taking our examples now, it takes time. If you given wrong, again it is disturb the class. If you take the example given in the book, so it gives our accuracy in the teaching, right? Clarification also, and you will get the more clarification. Okay, this is the trivial relation. Sometimes the relation, both empty relation and universal relation, is called trivial. Okay, the spelling is trivial. trivial, right? Trivial relation. Okay. Next one is identity relation, right? Identity relation. Let's take the identity relation. Third one is identity relation. Identity relation. Okay. In addition, okay, in empty set I explained that's okay. That may be correct or not be correct, but here for 0 plus 2 and 2 plus 0 we have 2. This is called identity element of addition. Okay, sir. Identity element for addition. right? Similarly, 1 into 2 is equal to 2 into 1. Again, we are getting same element. This is the important thing here. We are getting same element. Okay, one multiplying the 1, we are getting same element. This is called identity element in the multiplication. Okay, sir. Means identity concept means if you done the any operation on the same element. Okay. Any operation, I'm telling that if you do any operation, mathematical operation are done the same elements on the same elements, if you get the same element again, the result is also same element, then it's called identity element or identity relation. Here, let's check the elements 1 and not elements, you can call the elements also, but ordered pair is better. Technical word is ordered pair. Okay, ordered pairs 1 and 1 and 2 and 2 and 3 and 3, right? What the condition is here? Okay, if you take any, R is, if I take any, A should be equal to B and B belongs to A, right? My condition is R like that. R is equal to implies A is equal to B, where A and B belongs to A. This is possible, right? And see, do any operation. Okay, do 1 plus 1 is equal to 1 and 2. Again for this one, okay, again interchange it. 1 plus 1 is equal to 2. Okay, means 2 plus 2 is equal to 4. For this one, okay, these three are identity relations individually. Means 1 1 and 1 1 can 2 2, 3 and 3. Different individual, not collectively. Okay, different. This set, this order pair is relation. This order pair is relation. This order pair is relation. Therefore, this set is the set is called identity set, and this is the order pair is called identity relation. This is the identity relation, right? And that relation is the given. Okay, IA they given. Okay, right? IA identity element set is equal to 1 1, 2 2 and 3 3, right? See, if you're not seeing books now, you will miss this notations, right? This is the first one is empty relation. Empty relation is the beyond the sum and mathematical operation is gives the result not in the Cartesian products, right? Then universal relation, any operation done on the Cartesian product will get the whole set. And end relation is special. Okay, and empty and which universal is called trivial relations. Trivial relations, and this is the identity relation means done the any operation on the same element, same order of pair, we get the same again same result. That is the identity relation. So okay, next is these are the new concepts. Okay. Next one is here. From here, the real concepts, the real problem set starts from the for class 12, right? Types of relations on set, on a single set. What are the types of the relations you have? They given like that: reflexive, symmetric, and transitive. Reflexive, symmetric, and transitive. Before going to start the relation, just I'll take one example. Okay, let's take the example of the triangles, right? The all are equal side. This is the A, and the triangles I am taking again. This is the triangles B, and the triangles C. The triangles congruency. Okay, you can three sides are equal, two sides are equal, one angle are equal. SAS, SS, SS, and RHS. AS, AAS, that is okay, that be. But I am taking the three triangles to show these some basic concepts. Okay, A and B are similar. Okay, the condition is triangles are similar triangles, right? R is here. R is our triangles are similar triangles. similar triangles, right? Or is the relation is condition is triangles ABC are similar. Okay. First, okay sir, very important. Then first can I write as A is similar to B, similar to A, right? A is similar to A. They already given. Yes, A itself is similar to A, right? This is okay. This can I write as okay similar to A. So can I write this as A or A? Okay. Then if it is true, then this is called a reflexive relation. Or simply reflexive. Okay. This relation is reflexive. Okay. This is the one condition. Like that. Second one is second two. Okay. Second, if A is similar to B, triangle B, again, and B is right. B is also similar to A, right? They given similar triangles. Therefore, can I write as A or B? Okay. Can implies okay is equal to implies B or A. Then this is called, this implies okay, this is called symmetric. Very important terms are very important. First one is the reflexive, second one is symmetric. Okay, first one is reflexive, second one is symmetric. Okay, third one is okay sir. Third one is if okay, can I apply if also condition if A is related to similar to B. I am writing as not very similar or A is similar to B and B is similar to C, right? This can I write as implies A is similar to C because A is equal to B. Can A is equal to B, B is equal to C, then A is equal to C, right? Similarly, X is equal to Y and Y is equal to Z, and can I write X is equal to Z, right? Yes. This is called okay sir. This is called this is called transitive. And one thing I don't know why they are not mentioning these capital letters. They given in the small letters. Almost all transitive. Transitive relation. Transitive, right? Yeah. In headings also, they use the small letters for here. They make the dark lines and make the important things also. But still, they are using the small words. Okay, reflexive relation and small. Okay, symmetric relation and transitive relation. Okay. First one is A is similar to A. A is similar to A. It's called reflexive. Again, A is similar to B and B is similar to A. And A or B is equal to this one, and it's called symmetric. And A is similar to B and B is similar to C. They given, if they given, then next implies means it gives A similar to C. This is called transitive, right? If 3 are holds good, I mean 3 are true on a set, single set, this is called equivalent relation. Okay, sir. It's called equivalent. Okay, equivalent relation, right? equivalence, not valent, valence, right? Equivalence, right? Equivalence relation. If R is A on A, this is true, symmetric, and R is reflexive, R is symmetric, and R is transitive. Then the relation, the R is called, right sir? This R is called, okay sir, R is called equivalence relation. R is called this R. R means this is the word similar, means similar relation. This relation, okay. Similar triangles, similar to, okay. Similar relation called, okay. I can tell any in similar way. Similar relation or similar triangle relation is equivalence, okay. Equivalence relation. Equivalence relation. Very good, okay. The mathematical notation, will see the how the mathematical notation is written. Okay. Let's see the mathematical notation of writing this. Okay, in rough you write taken the reflexive, symmetric, and transitive. Mathematically how they are writing, let's see. So I write on the board. One, okay, technically how the system, the relation is symmetric, reflexive, symmetric, and transitive. Okay, then how we should write in theoretical form, technically, exactly in mathematically. Okay, technically, mathematically how should you write this one? Okay, this let R be a relation on a non-empty set A. Okay, this is a non-empty set A, right? Then R is called a relation, okay, a reflective. Using A, R is called a reflexive relation. Say I am skipping the relation here. Reflexive if, okay, A or A, that is A order pair, A and A belongs to us for all A belongs to A comma A, okay, A bracket, okay, belongs to R, means same elements. A or A, relation A plus A minus A into A by B, A by A, whatever it may be, A or A in general. That is A and A belongs to R, then for all A is equal to, for all A belongs to A is called reflexive. This is followed. Symmetric, if and only, this is if and if only. If and only if symbol, okay, very important. This one is if, means if and only if. Only if means only this condition, okay. See, only symmetric, okay, means if and only if A is equal to A or B and implies B or A, that is AB belongs to R and BA belongs to R, and for all AB belongs to, okay sir. If and if only A related to B and B related to A, that is AB belongs to R implies BA belongs to R, and for all AB belongs to A, then if and if only this is, then R is symmetric. First this one, if it is, then this is similar, okay sir. Transitive, if A related to B and B related to C implies, right, this is the implies symbol, A related to C. If A or B and B are true, I imply that A or C also true, okay. That is AB belongs to R or BC belongs to R implies that AC belongs to R also for all ABC belongs to A, okay. This is called reflexive, okay, the transitive relation, okay. If R follows all these three relations, then R is called, okay. Okay. Then if R all it is, okay. If R, then it is called, if R has the follow three relations, then R is called equivalence class. What is the equivalence? Equivalence relation, right? And this is the first concept only. Let's see the, okay, this is the basic introduction. What is the relation? First of all, I define the area subset on the set A cross A, right? Similarly, next we solve the some question similar to similar triangles to show the how the relation is reflexive, symmetric and transitive. If the relation is symmetric, transitive and the relation is reflexive, symmetric, transitive, then the relation is called equivalence relation. Okay, sir. Based on this basics, we will solve some questions, previous questions. Okay, then we will solve the next concept, right? We solve the one question. One question is from the JEE recent questions. Let's see what is that. Okay, students. This is the question from JEE Main Shift 1 2023. Based on this chapter, question number 68. Okay. Clarify the once again. Okay. I have to take a print up from the Motion Institution. Motion, MOTION. They may be accurate or not. Okay. But my knowledge, Shift 1. JEE May 2023. So this is the question with the relation R is AB such that GCD of AB is equal to 1 and 2A is not equal to B and AB belongs to Z, integer value, integer number is. They are question they given fourth one, okay. Only reflective, not transitive, only symmetric and not transitive, neither symmetric nor transitive. In something they given, okay. See, sir, I will show the one by one. So let's check the reflexive, okay. However, one should take the two values such that A2A is not equal to B. Means should not take the value. Okay, a Z integer, you know, integer is minus. Okay, sir, up to minus infinity, minus infinity to minus 2, minus 1, right? 0, 1, 2, up to positive infinity. Then the integer value set. Should I take the value like 1 and 2? Okay, A is equal to 1. Okay, A is equal to 1 and B is equal to 2. Okay, or A is equal to, so I should not take the values like that. A is equal to 4 and this one B is equal to 2 because 2A A is equal to 2, A is equal to 2 and B is equal to 4. And this is not valid because they given 2A not equal to B. See, in these exams, this is the concept, okay sir. This is the condition. A question is based on these simple questions, but they will give the applications to think beyond this one, okay. Okay, this is also not good, okay. Again, you will get the same value, right? So here I can take A is equal to 3 and B is equal to 4. Can I take this one as? Yes, sir. Can I take this one as 6 and 4 and C? I will take two values. Okay, then and A will take 4 and B will take 4 also. Can I take this one as R8? I will take the two values. Let's check the reflexive value for, okay, for A is equal to 3. Okay, can I take 3 is what is the GCD of, okay, before we start, GCD is greatest common divisor, okay sir. GCD is the greatest common divisor, greatest common divisor, okay. Then if we take 2 and 4, okay, can I write 2 as 2 and 1 and 4 as 2 into, okay, 1 and 4. This is the GC common divisor. This is the factors now. divisors. So this is the GCD of 2 and 4 is equal to 2. But our condition is GCD should be 1. In simply the prime numbers only. They given the prime numbers because of GCD of the prime numbers is 1, right? If I take an A as right circular, okay, what is the condition? Okay, GCD of, right, GCD of 3 and 3 is 3. So means here GCD of 3 and 3 is not equal to 1. So this is not reflexive. First condition is failed, right? It is not reflexive. First condition is failed. They say second one, right? If A is equal to 3 and B is equal to 4, right? Yes, GCD of 3 and 4 is equal to which one? 1. This is right, right? But take the again random values. A is equal to 4 and B is equal to 8. Because they given the A, B is a arbitrary constant, belongs to Z. You can take the any value of the Z, right? That's so. GCD of 4 and 8 is 4. Therefore, GCD of 4 and 8 not equal to 1. Again, it is not transitive. Okay, you should write this is transitive, also not symmetric. Not symmetric, right? Not symmetric. Then take the C value like that, some 10, right? Any value, you can take the any values. Okay, where I should do, I'll do here only. Okay. I'll take the GCD of 4 and 8. Okay, you can take the 4 and 8 is 4, means not equal to 1, and the GCD of 8 and 10 is, what is the value? 2, right? 2 is not equal to 1, and GCD of 4 and 10 is equal to 2. Okay, 2 means 2 4s are 2 5s are. Again, this 2 2s are 2 5s are. 2 4s are 2 5s are. We got one odd number, can't go. So this is also 2 is not equal to 1. I am writing this only to understand, not exact method writing, because you should write this one as GCD of 4 and 10 not equal to 1. You should write in exam. Okay, therefore not also not transitive, right? Don't take the gap. This one is correct. The twist is here. For prime number is correct. For all arbitrary constants is not correct. For all arbitrary constant is not correct. So therefore, GCD of, okay, there R means R is GCD of 1. A plus B, A minus B, A into B, A to the power B. They given GCD. R, the condition is, relation is GCD is equal to 1. Okay. Then this is called, this is not reflective, not symmetric, not transitive. Okay, sir. Therefore, you can tell this is the not a, okay, relation also you can tell us. Okay. Okay, not relation, you can spelling on not, okay, so instead of spelling not relation, it should not be not neither reflexive nor symmetric and transitive. The answer given is neither symmetric nor transitive. Okay, sir. Answer is for this one is fourth one. Neither symmetric, nor transitive. Fourth option, right? Question number 68. This is the pattern, the question they will ask in the basic questions. Okay. Now from next class we'll solve the again from the this is the basics only. Again from the basic concept we'll solve some different concepts. Okay. So this is my first class in the class 12 mathematics. Okay, sir. Even though and I'm telling again and again, this is the my first year experience. Okay. It makes some turbulence while teaching on me because I remember I will forget the concepts. I will give some wrong mistakes also. So those who are seriously watching, okay, sir. This is I'm uploading on YouTube only my personal expenditure to get the knowledge. Okay. Everyone the teaching reading is different and grasping the concept and teaching by on the board is quite different scenario, right? So where it may be problems, please comment on the comment box, and if something I have made mistakes in some books or points taking consideration, take the screenshot or take the page number also, just send it to me. Okay, and give the feedback either positive or negative. Let me all of the feedbacks are accepted fairly and lovely. Right? Okay, bye, and thank you for watching, and see you on the next class. Bye.